GitHub to launch GitHub Actions. I actually joined as a full stack engineer, and I thought I was going to be writing loads of TypeScript to build a very cool visual editor for the original version. And then they, in classic startup form, just got rid of that feature, and suddenly I was a backend engineer writing Go all the time. And running Go is one of those things that's pretty easy. If you've written anything in a type language, it's very familiar. If you've written any imperative language, you kind of feel like you're somewhat competent, a couple of days in. You can read and write it straight away. It's like a slightly more complicated executable with pseudocode than Python, but I still feel like it's pretty easy to feel like you're competent. So it felt good. Like I was writing Go code, I was getting stuff shipped, and this really pays off. Like this is the kind of design goal of Go. Legit, it worked. It was good until a rude interruption from my ignorance occurred when I realized that the very familiar feeling Go interfaces weren't all that familiar. So I've been using TypeScript a bunch. I'd used other type languages before, like back in the day. So I'd like to kind of take you through this journey where getting tripped up by this feature forced me to learn Go properly for the first time. And I really think that if you dig deep into interfaces, it's like the 80-20 for Go. Like it was the 80-20 for Go before generics, and it's the 80-20 for Go now. Like if you understand Go, like interfaces in depth, you pretty much grok Go. If you don't, you're always going to be kind of like an advanced beginner. You're never going to really get it. So let's go back to the beginning. This is, of course, an interface in Go. It looks very similar to many other languages. You define a bunch of methods, and you're away. And of course, if you define a type which implements the methods, it implements the interface. Everything's great. So if you play around with this a bit, you can see it works how you'd expect, which is lovely. Very similar to other languages. So you can see the compiler is not going to get upset by this. Everything compiles, everything's good. Here we have a user. User has the one method in that interface. We can put users into a named. A user is a named. Fantastic. Very cool. So what can we do with a user when we need a named? Can we pass it into functions that accept a named? Well, yeah, of course we can, which is great. So where's the bit that tripped me up? What's this? So you can see now we start off with a method taking a single named. So we're taking a single named value. You can see we're creating a user struct. We can pass it in, it compiles, everything's good. But then we go to this. What we're doing is making a slice of named. Does this compile? And we know the user is a named. What we're doing is taking a slice of named. We know that it's surely a subtype. Like a slice of named, surely a slice of user is a subtype of slice of named. No, it's not. And this was the bit where I was like, whoa, what's going on? I thought I was basically, a Go expert. I've been writing this for like 3 months. I've shipped loads of features. Nothing has exploded. And yet I can't explain to myself like why this doesn't compile. And this is what it kind of got interesting. So this is our kind of our mystery. And then one of the first things I did actually was to go back to a language I understood a bit better, TypeScript, and have a go. So I did exactly the same thing. Same code, user, named interface, and it's fine. No problems at all. And then I just out of interest, tried it in Java, same thing. Everything's fine. So what's going on? Now at this point, you might think, my product manager, my engineering manager is going to chase me down and kill me if I don't get stuff shipped. So why don't I just try and do anything that works and get on with my day? So if it was in TypeScript, I might just try a slice of any, or array of any. Let's give that a go. Does that work? Will it work? Will it compile? So in theory, slice of any, slice of interface, empty interface. Just as a reminder, empty interface and any are interchangeable, same thing. You think it would work, right? It's kind of any. It's so tempting. You've got to try this, please. I've got to get this shipped. No, it doesn't compile. So what is going on here? Why is Go doing this to me? Why don't collections of interface values work like any other language I'd actually used before? Interesting. Now, I've been programming for a while, and what I was doing when I was trying this slice of any was something I recognized from many other times before, which is I was thrashing around. Like I was confronted with something I didn't fully understand, and I was trying to just get out of it. So thrashing for me is when, you're flashing around like a fish. You're like, oh my God, this is awful. I feel like a complete newbie and an idiot and a fraud. And I'm just going to try and get something shipped, you know? And we thrash around for what I call kludges. You know, this is when you don't fully understand your tool and you're just desperately trying to find something that will get you through the feature. So it looks different in the different languages, right? Like Git, I think the classic is when people tell you to just check the branch out again. Like, let's just not try and understand what's going on with these crazy, you know, badly named command line tools. Let's just check the branch out again. And pretend it didn't happen. Set timeout in JavaScript. If you ever see one of those for no reason, no good reason, probably a clutch, right? TypeScript any. If you don't understand the type system, you just want to get on with your day, people chucking in any. And in Go, like a time sleep. Or many languages, to be honest. Anytime you see a time sleep for no reason, just like set timeout. And these are the two paths before us, I find, when you confront one of these times you're thrashing around, the kludge and getting curious. If you take the kludge all the time, I think you're eventually going to end up with a kind of classic advanced beginner. You're really not going to understand your tools in depth. You're always going to be confronted by this stuff and just kind of try and dodge it. Getting curious is where it gets interesting. And I still think that if you get through the day with kludges, still kind of a defeat. Like, you don't want to get nerd sniped all the time. I do agree, there are times, there are deadlines, but I would definitely like take a pointer and come back to it and learn it properly. So, let's get curious. Now, there's nothing wrong with this. We know for sure this is working. Like, user definitely implements all the methods in name. There's nothing to do with that. That's not the problem. And we know for sure this is true. This is kind of where this is the interesting mystery, right? We can use a user where we need it named all the time. We can use it in single argument functions. We can use it in values. It's all working fine. So specifically, what's up here? Now, there may be people who grasp language very well and are thinking like, what's going on? This is clearly not allowed by the specification. Or there may be people thinking of the words like contravariance, bivariance, all that kind of stuff. Maybe they did like a type 3 thing. Now, both of those are like the rule lawyer answer, okay? They're going to say like, this is not allowed by the spec. And this is true. Now, this is interesting about Go. Every single slice with a different element type is a distinct concrete type. And concrete types can have methods attached to them, so that's how you can tell. But you can't do this to an interface of any type. You can't attach methods to interfaces. You have to have concrete types. And this is a rule that you cannot use concrete types interchangeably, you can't assign. So that's one answer, but that's just a rule answer. That's not an interesting answer because it doesn't explain why it can't be true. You know, this isn't real knowledge. This is just repeating something from the spec. Why couldn't Go work like this? Because Go does work like it in lots of other places in a way. Like Go is designed to be expressive, clean, concise, and it does things for you, which is kind of interesting. So we don't have to do the line below, which is like the kind of Java-y way of doing it, with like a zillion repetitions. We can just write this and Go figures out all the rest. Like it can implicitly realize you're trying to create a user value in that slice, etc., etc. So if Go can figure out how to pass a user to a get name, why can't it do the same with the slice? Now, what started to give me a hint here was when I was reading the spec and trying to understand it, it said variables of interface type have a distinct dynamic type. Value assigned to the variable at runtime, stored in interface values. And that was a really weird way of putting it to me. Stored in interface values. That is not how I talk about interfaces in any other language. Because my mental model here was effectively like, we had a static type value. The static type of the value was a named interface, and just inside there was a user, the bits and bytes of the user. But what seemed to be happening was something different. It was talking about two different things, a dynamic type and a dynamic value, which is really weird. My mental model was clearly wrong. See what I mean here? Other languages, interfaces are kind of a thing that a value of a certain type can do. Go seems to be different. Go interface values were a different type of value, not an attribute of other types. Super interesting. Go interfaces felt more like a container, a value of named containing a user. This is the diff, this is the delta between my old mental model from a different language and Go. Container for concrete values, rather than an attribute of concrete values. So in Java, you'd say like a user is a named, whereas Go seems to be wanting me to think about it like I'm putting a user in a named, in a interface value, with a static type of named. Super interesting. And it's kind of the very concision and expressiveness of Go that's creating this confusion, because it's doing things behind the scene to make a compiled language, which is actually very fast and quite kind of like clean in the compiler design, but it to us looks simple. This is what's kind of creating confusion, this elegance of the line. The fact that we can do this stuff, without having to get so explicit about like creating a named container for our value, was making me feel it the wrong way. But if it can do this for single values, why can't it do it for slices of values? Like, couldn't it do that? Couldn't go with sufficiently kind of complicated compiler do this for us? Could it? Could it not? Don't know. Interesting. Well, let's think about this method over here. Switch items. So you can see it's taking a slice of any. We're taking two indices and we're switching them. Now, if Go did something clever to convert this slice of user into a slice of any or a slice of named, would this method work? Could it work if you got down to the bits and bytes? If you were implementing Go, would this be possible? You could think about an implementation, right? So we've got this slice of users, and imagine there was this like imaginary compiler thing going on. Or these lines of code. You could imagine it allocating a new slice, popping the things in, etc., etc. Well, even if it did this for us, it wouldn't work because we'd be switching the wrong thing. Because again, an interface value in Go is a container for values. You have to create the container. It's a different shape in memory from your value. You have to put your value in it. So if you want a slice of those things, you have to create a new slice with a different shape, with a different size. Because you can put anything into an interface. It could be like a ginormous type, a struct with like 1,000,000 64-bit ints, or it could be a tiny type like an int8, but it's always the same size. Whereas those concrete types will be very different size slices that have different size backing rates, etc. So this wouldn't work. Okay, cool. So this is the delta I got to this implementation, right? The delta for the intuition. Slices of interface are a distinct concrete type was the rule that we heard about, and then this is my intuition at the bottom, like interfaces, containers, and values. So I wanted to go a little deeper. I wanted to know what were these interface values? What did they really look like? This is our intuition. Let's look at them from a runtime's point of view now. Okay, so what does a struct look like in Go, in memory layout? It's actually kind of cool. Like in memory, it's just the size of all the fields in the struct. The type actually exists at compile time. It doesn't exist at runtime. There's no additional memory stored for the type. We already know the type. We did it at compile time. Kind of interesting. So if you had like nothing in a struct, how many bytes of memory would a struct cost at runtime? 0, right? Which is super weird, super confusing to me, like when I first realized this. And it's one of those cool things about Go. So if you add, let's say, 8-bit ints, you have a 64 byte struct, etc. Now, a interface value has what's the size of an interface? Well, the size of an interface is actually the size of 2 pointers. Because what it has, A, is a pointer to the value, and then sometimes some optimizations, etc., but you can ignore that. But more importantly, like a pointer to the type. And that's what's going on. But you can see, importantly, although we are storing a user in a named, in memory looks totally different. There is no similarity in terms of like the bits and bytes on the stack or in the heap between an interface value containing a particular type that implements an interface and the type itself. They're just totally different looking things. And that's why we couldn't do any of this magic, right? This is the kind of interesting thing. All interface values are the same size. We could try this out with unsafe size of. You can see these kind of interesting things. Kind of cool to play around this. You might surprise yourself and get curious about new things. So you can see those 3 interface values over here. And again, any is shorthand for interface, MG interface. They all have the same size, right? All pointers. Does this do anything beyond supposedly helping you understand? Well, yes. The whole Reflect package, completely powered by this concept of dynamic type, dynamic values. It's all about interface values. You can't do anything interesting with Reflect without interface values. You can basically see them as the 2 sides of exactly the same feature. And if you don't understand interfaces, you do not understand Reflect. You cannot understand Reflect, I would posit. So let's have a look at this. What's going on over here? Value of. What are we getting out of this? We're getting a reflection value telling us about the dynamic value in that interface container. What do we do when we get type error? We get a type telling us about the type. And then we can do cool stuff with reflect, etc., etc., etc. And I find, yeah, as I say, easy when you know about interfaces. So some homework for you. Go read this amazing blog post on laws of reflection. Once you understand interfaces, you'll find this easy. If you find this a difficult read, you need to go back and learn more about interfaces. Kind of an interesting one. Okay. Hopefully we have a new intuition for what an interface in Go is, and hopefully we've also made it a little more concrete and understood a bit about like it's actually a different thing in memory from the values themselves. So now I have a little challenge for you. Kind of fun. Will this work? And what will happen at the bottom? So you've got a couple of print statements. I just want you to kind of reason through what these are going to print out. And by the way, if you print out one of these values, whether or not it's in an interface value, it's going to be like the string. So it'll be A or B. So at the beginning, spoiler alert, the first line will just be A, B. And then we're going to call this switch ibars. Now first off, will this compile? If it compiles, why? And then secondly, what are we going to see for I1, I2, and U1, U2? Anyone want to take this challenge on? Like, understand that no one does, a little scary, but definitely go for it. Also, I have no idea how much time I have.
It's been 16 minutes and 30.
Fantastic. Okay, we're doing quite well. Okay, so we've got the switch. This is not supposed to be part of the puzzle, right? This will just switch the two values that are in those things. That will work. So you can kind of assume that's doing what it says. So yeah, don't worry about that topic because that is hideous. So what's I1, I2 going to say? Will it compile first? Are we, by our kind of intuitions, could this be possible? Yeah? Not doing anything that breaks the rules of cool. Makes sense. And then what are we going to see for I1, I2? Will the switch actually work? Sorry? Well, I'm not sure it's completely true, right? Because very often it'll compile but do something different from what we were expecting or hoping. That's the kind of classic bug. But yeah, fair point. It will do something. It will definitely execute.
Swap the interface values around as a container.
Yep.
We swap them around.
Yep.
It won't swap the underlying type. It'll swap the.
Yeah. So yes, absolutely. Actually, it's like failed to redact this very well.
Oh, what?
Sweet. Classic. But yes, so what's actually going to happen, it will compile, well done, and we're going to switch those interface values, but we will, of course, well, not of course, but interestingly enough, we will not have switched the original values, right? Because what we've done is create two containers, two interface values, those double pointer thingies. We switch them around, it's fine. And also, of course, well, not of course, this is one of the other weird, interesting things about Go. Every time we reassign a value to another value, whether it's like in a function or a return or just literally doing a variable assignment, we're creating a copy. That's another interesting thing about Go, right? So when we put that user into the interface value, because it's a struct, we've copied it. And actually nothing we do to the user in that will affect the original. So yeah, you can see we have compiled, we have switched to interface values, and we have not affected the originals. Challenge number 2. So what I've done over here, I've commented out the interface values, so we're not doing interface values anymore. I've commented out the print, and I'm just taking the address of the users. So we know user implements named. I've kind of made that pointless anyway because we've got any, but anyway, we're just going to see if we can switch the interface values. We're going to see if we can call this function. Will this compile? And if so, what will happen?
It will compile and will be switched.
Good guess, but not correct answer.
I don't think it will compile.
Yeah? Why couldn't it compile? Because we could write a compiler that could do this, but why would it not be feasible?
Because the type is technically wrong, but the interface is a container. So
Yeah?
you're giving it a user.
Yeah?
They're
Totally.
pointing to different things.
Pointing to different things. Yeah, this is the interesting thing, right? Because what this needs is a pointer to an any, okay? Now we know anything can go into an any, right?
Yep.
That makes sense. But if we implicitly created an any, put the user in it, and took the pointer to that value, and switched it, we would not be doing what we kind of wanted to, right? We'd just be switching these implicitly allocated and therefore like impossible to access values. There'd be no point in doing this, right? Like you create on the stack maybe in your compilation, and then you switch them, and then you'd be like, well, I can't get that. Like it's invisible to me. Kind of interesting. Here we go. And this is the error it would get. It won't compile because it wouldn't work. And it says, you know, blah, 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 blah. Again, this is interesting because this is like the spec / like compiler type telling you what it's not going to do, but it doesn't quite tell you why it couldn't be possible, right? And again, because if we did implicitly allocate these things, which I think has over here, if we did implicitly allocate these new values, we would be swapping the wrong thing. So imagine we could implicitly allocate these interface values. So here we go, create the any's. We take a pointer to those values, we switch them, we switch something that we couldn't access in our language, so completely pointless. Super. All right, well, hopefully that's given you either confirmed your existing intuition for interfaces or given you a new one, and giving you a little flavor of what's going on under the hood. Cool. And hopefully it's made you a bit more curious about how Go works under the hood. I recommend digging in. So we've tamed interfaces. Congrats. Nothing too more to it. Like great. Move on with our day. We all feel great about Go.
Exactly.
Damn.
And you challenge our viewers.
Damn, exactly. Yeah, generics have entered the chat. This is bad times for everybody because I've got another challenge. Okay, here is a very short function, or a couple of functions, and this is a generic. We've added a generic. We've got a slice of something, and the something is any. So we have a slice of any. And you can see I'm passing in a slice of any to 1, and that one function is passing a straight answer 2. Does this compile? If so, why? If not, why?
The container types. Any is an E and D. That's what it looks like.
Oh yeah. Oh no, we're using us. Oh yeah, the 2. Yeah, right.
What did
Is that a
complain?
format statement?
So
Sorry.
did complain that S is not a type of array of any. List of any.
Yeah, it will, which is super confusing. And it's kind of interesting. It says exactly this, which is like, what? Slice of any is not a slice of any? Fantastic. Thanks, generics. Brilliant. And it's not a slice of any for a totally different reason, or kind of a related reason, but slightly different from the one we've done before. And with your understanding of interfaces, you can probably work it out, but you will also need to learn a bit about generics. And in a very annoying Stranger Things kind of way. That's a story for next time. Cool.
Yeah.
And also, I'd like to talk about this briefly. So I've been programming for ages now. I don't even know. I feel old. I'm 34. Very old programmer. And I feel like one way that our learning slows down as we get better at anything, right? I find it's easy to plateau. And one of the reasons I think is that early on, we get continuously bombarded by stuff we don't know and we don't understand. But we don't feel too bad about that, right? Because it's not a big part of our identity. We just started to learn the piano. We're just like, whatever, it doesn't matter. We don't know anything about it. And then later, it is kind of a big thing. We are like, oh, I'm good at this. It sucks when I don't understand it. But it's exactly that time. That anytime you feel ignorant and you feel like you don't understand stuff, you have to grab it and not let it go away. Because that is the moment, the rare moment you're actually going to be able to learn something new. And it's it gets hard because we don't often recognize this stuff. I don't know how much random woo-woo Buddhist stuff you read, but this isn't a conscious thing. It's not I'm going to avoid this because it makes me feel bad. You won't even notice most of the time. It's going to hide from you. You're trying to dodge it subconsciously. And it's annoyingly precisely at the point we most need to, if we want to level up, we most need to realize those gaps in our knowledge. Now I think getting curious and just continuously admitting to yourself you don't know everything and never will is brilliant. Because to me, going from not knowing something to knowing something is one of those like amazing feelings. Like if I've done that in a day, I feel brilliant. And I feel very lucky to be doing programming because it happens all the time. Doesn't matter what you're doing, there's always a lot more to learn. Once you've mastered Go, you can go and try and understand networking. Once you've done networking, you can go operating system, and then try and learn CSS, the ultimate challenge, the top level CSS3. Jeez, never doing that.
Yeah, I'm never doing it.
Thank you so much for listening. Like I said, there is a blog post forthcoming, so go use RSS. Sign up for my blog. RSS.